Today, we are going to be learning about reflection and refraction regarding light. First, we need to understand a bit about the characteristics of light and how it interacts with different surfaces or objects. Light travels in the form of rays, and when light is emitted from a source and interacts with a different source, the rays will either reflect off of the surface of an object in a different direction. This is what we refer to as reflection. The light rays can also pass through one medium and continue into another medium on a new straight-lined path. For example, if a light ray passes through the air and then is refracted inside of the water, that's what we refer to as refraction. Another thing that can happen with light rays is they can also be absorbed, just depending on what the surface is. We are first going to talk about reflection. So in this image, we can see two rays of light. The ray on our left is called the incident ray. That is the ray that is emitted from the source of light and is incoming to the surface. The second ray, the ray we have on our right, is the reflected ray. It's the beam that is then bounced off of that surface. These two rays form angles. The angles are measured relative to the perpendicular to the surface at the point where the ray strikes the surface. So that's what we see, the dotted line in the middle. And the two thetas are what help us define the law of reflection. The measured angle, theta I, is the incident angle, which is the angle measured based off of the perpendicular and the incident ray, the ray that has not yet bounced off of the surface. On our right, the side with the reflected ray, we have the angle of reflection, which is resembled by theta r. Just like the angle of incidence, which was on our left, the angle of reflection is measured to the perpendicular to the surface and the reflected ray, which is the ray that has already passed and bounced off of the said surface. With this, we are able to understand the law of reflection. The law of reflection states that the angle of reflection is equal to the angle of incidence. And this is very useful when we have to calculate how the light is reflected or predict what the angle of reflection will be. How we see an object depends on the light that is reflected off of the object's surface. So really, something crucial for us to understand is that whether or not a surface is smooth or rough affects how the light is reflected off. And this brings us to the two types of reflection. The two types are specular reflection and diffuse reflection. The first one we'll be talking about is specular reflection. Specular reflection is when light bounces off of a smooth surface and the ray is reflected in one direction. So again, if we imagine that this surface was a mirror, the light that's reflected off and how we can see our reflections so clearly are because of the smooth characteristics and the fact that the light is only reflected in one direction. So with specular reflection and objects like mirrors, spoons, just clear and smooth surfaces, you would only be able to see the reflected light if you were observing it at a particular angle. That's the most important takeaway from specular reflection. The second type of reflection that we're going to talk about is diffuse reflection. So in this image, we can see the light rays, which are supposed to be represented by the blue arrows, how they're going in various directions. So diffuse reflection occurs when light is reflected off of a rough surface. And when it is reflected, it's reflected at several different angles. The reason why it's called diffuse reflection is because as the light strikes different parts of the rough surface, it becomes diffused or reflected in all these different directions. So things like people, clothing, paper, walls, basically anything that has rough surfaces emit this type of reflection, this diffused reflection. Because of this type of reflection, we're able to see these things from all angles, not only at a specific angle, but if I'm standing far away from a wall or close to a wall or to the side of a wall, I can still see that it's there. And that's due to the rough surfaces of the walls and the light being diffused and reflected in all these different angles. This picture is an example of reflection. I was on a hike one day and saw how gorgeously the mountains were being reflected off of the lake. So this is due to the shiny but uneven surface. So as we can see, the reflection is a bit larger in the water than the actual image of the mountains themselves. But the reflection would be a lot clearer if the lake were calm. So I just thought this was a really neat example of how we can see reflection in everyday life. Now we are going to discuss refraction, which is a bit more complicated than reflection, but hopefully once we get through the end of this video, it will make sense. So refraction is the changing of a light ray's direction, which can be loosely referred to as bending, as it passes through different mediums or variations of matter. So let's just look at this image on the right here. We see the glass filled with water and the popsicle stick inside of it. At a glance, it looks like the popsicle stick has been broken or bent and appears to be magnified. But we'll just keep this image in mind and be able to discuss it a little bit later when we understand the principles of refraction and why the image appears to look like this. This diagram here will help us understand how light is refracted. So, like in reflection, we have an incident ray, which is the ray of light that is passing through the first medium. And then we also have a refracted ray, which is the ray of light that then passes through the medium and is refracted. So with these two light rays, like in reflection, we have the angle of incidence and the angle of refraction. And these are measured in relation to the normal of the two mediums, of where the light ray goes in and passes through the medium. And the reason why the refracted ray is a bit appears to be bent and has the angle of refraction is smaller is because light changes direction when it's passing from one medium to another. That is what refraction is. And in this case, it's changing from air to water. But why does the light change the direction? Why is the angle of refraction smaller than the angle of incidence? It's because the light is changing speed. And understanding that the light is changing speed is really important for us to understand as we discuss the different indexes of refraction, which is what we're going to be talking about now. So, what is an index of refraction? An index of refraction is measured by the velocity of light in a vacuum, which is generally 3 times 10 to the 8th, divided by the velocity of light in the medium. So the velocity or the speed of light is actually changing as it enters different mediums. So over here we have this chart and we can see that air has a smaller index of refraction than water does. And in these substances, these indices of refraction help us understand how much the light is changing speed and by how much the angle of refraction will be affected by these changes. And basically, what the index of refraction tells us is how easily light rays travel through different materials. So, like we talked about air and water, light can travel a lot easier through air than it can through carbon disulfide. And we can see that based off of the different indices of refractions. So for example, we can talk about light and water again. So light moves slower through water than air because the water has more atoms. This leads us to the conclusion that the denser the medium, the slower the light moves through that specific medium. So like we said, carbon disulfide, the light will move a lot slower through the carbon disulfide than it will through carbon dioxide. So kind of this understanding of the densities of the material do affect the angles of refraction. This brings us to the law of refraction. So much like reflection, we have the law of reflection, and for refraction we have the law of refraction. So up here it's written in its equation form. N1 sine theta 1 is equal to N2 sine theta 2. That is also referred to as Snell's law. But basically put into words, the law of refraction is the index of refraction of a substance times the sine of the angle of the incident ray. So that's what we would see back at the beginning. That's what we'd see over here. So we would do sine of the angle of incidence times if this was air times the index of refraction of air is equal to sine of the angle of refraction times the index of refraction of water. And that's what the law of refraction is. And so with us being able to understand indexes of refraction and densities, we are able to calculate or predict basically how the light will be refracted in a certain material. Sometimes this is a bit confusing, but now we are able to see why it appears this way. So because the water has a higher index of refraction than air, the light is moving slower, thus making the popsicle stick appear to be bent or bigger. And this is how we see, like if we put a pencil in water or sometimes fish tanks. This is just another example of different densities as the medium is rougher, coarser, or denser. Like grass is harder to drive on than a sidewalk. So depending on the differences in how smooth or rough a surface or medium is, we are able to determine which way the angle will bend. So on the sidewalk, whether it's the refracted ray or the incident ray, will be greater than on grass. I really hope you all enjoyed this video and were able to understand a little bit about both reflection and refraction and are able to apply these concepts in everyday life. And here is the work cited. Thank you very much.